been getting a lot of requests to do some more problems that are what I would call analytical problems rather than numeric problems, where instead of being given prices like $3 and $10 and an actual budget, we leave everything as variables. So here's a problem where we're going to go through and derive some demand functions and calculate some expressions for elasticity where we leave everything as a variable so we can get a general analytic solution to these things. So we have two consumers here, A and B, and they both have the same level of income. We're going to call that M. They spend their income on X's and Y's. We're going to call the price of X P. We're going to call the price of Y Q. And we have two different utility functions for these two people. The first one here for A is a standard Cobb-Douglas utility function written in its simplest form, x to the alpha times y to the 1 minus alpha. B's utility function is one for perfect complements. So when we look at A's indifference curves, they're going to have a typical kind of shape that we see for a Cobb-Douglas. The actual curvature here is going to depend on those two parameters, alpha and 1 minus alpha. B's indifference curves are going to look like an L shape. For perfect complements, you don't get any more utility unless you get more of both goods. And again, the exact shape or the exact kind of relationship between the legs of the 90-degree angle here are going to be given by the alpha and the 1 minus alpha. That's going to tell us the proportion in which B prefers to consume X and Y. Let's go in and start doing some of these derivations. And I haven't prepared my answers beforehand. I am going to just let you see what my thinking process is as I go through these problems instead of presenting a polished solution. So I might make some mistakes, I might rethink some things, but watching me do it in real time instead of presenting you the final answer is where I think a lot of the help comes from watching somebody do this. So let's first take A and derive their demand functions for X and Y. I'm going to include a link in the description below where we could use a Lagrangian to do this. That just takes more time than doing the simpler method where you take the marginal rate of substitution, which is the slope of an indifference curve, set it equal to the ratio of the prices, and then solve this for X or Y, and then plug it into the budget equation. It's exactly the same process as the Lagrangian, except it saves you some of the setup and some of the math. I'll include a link to my video showing that those two are indeed doing the same things. So the marginal rate of substitution, again, there's a shortcut for getting the marginal rate of substitution for a Cobb-Douglas. I'll include a link to that video as well, is just the exponent on the X. So the exponent on the X is alpha times Y, and the exponent on the Y, so that's 1 minus alpha times X. So that tells you what the marginal rate of substitution is. Set that equal to the ratio of the prices. Well, we're calling the ratio of the prices P and Q. So here, let me rewrite that as P and Q since that's what we're doing in this video. All right, so that's our what I call equation number 1 when we're doing this kind of problem. Equation number 2 is just the budget line. So price of X times X plus the price of Y times Y equals our budget. And in this problem, they say to call that M. Okay, so instead of calling it B for budget, we'll call it M for the amount of money you have. And then what I like to do is usually solve this equation for Y and then plug it into the budget line. So let's go through and do that and see what happens. So let's multiply both sides by the denominator here, and we'll end up with just alpha Y on the left-hand side equals P over Q times 1 minus alpha X. And then we just need to divide both sides by that alpha, and we're done. Now we want to plug this entire expression into the budget line where we see Y over here, and we're going to end up with Px plus Q times that entire expression over there, P over Q times 1 minus alpha X over alpha equals the budget. And now what we want to do is go through and solve this expression for X. And that will give us a demand function for X. as a function of the price of X, the price of the good Y, and the budget. So our strategy here is going to be to try to start simplifying things, and this is one of the things you just kind of have to get used to when you are doing these analytical solutions. They're going to be a little messy. Really, we want to take this large chunk over here and start seeing what we can simplify. And the first thing I see that we can simplify here is that this Q on the outside, when we multiply it times something divided by Q, over here, those two Q's are going to cancel. So that's the first thing I would do. And let's just rewrite what we have after we cancel those two Q's. So we're going to have Px plus P times 1 minus alpha x divided by alpha equals M. Okay, that's looking a little easier to digest already. Now we see that there's a P in both of these sides. So if we want to solve this for x, we could go ahead and divide both sides of this equation by p. And that's going to leave us with x plus 1 minus alpha over alpha x. So I'm just collecting this part as a fraction. Multiplying times x equals m over p. And then we can collect these x's. And so we have 1x plus 1 minus alpha over alpha x equals m over p. So we have 1 plus 1 minus alpha over alpha times x equals m over p. And then we want to divide both sides by this multiplier expression right here. All right, and that's going to be our solution for x. So let's just clean that up just a little bit and write it over here. X equals m over p. And instead of dividing by that, let's just multiply it by 1 over that. So times, that just looks like a cleaner way to write this. 1 over 1 plus 1 minus alpha over alpha. So that's our demand function for the good x. Now usually when you have something ugly like this, there's going to be a way to simplify this quite a bit. And often it's not easy to see exactly how you would do it. Here's how I would try to attack simplifying this thing down. We have a 1 minus alpha over alpha. Let's see what happens if we convert this 1 here to alpha over alpha. So let's just work with this big thing here, ignoring the m over p for a minute, and see if we can make that look a lot nicer. So I'm going to replace this number 1 here with alpha over alpha, because alpha over alpha equals 1. And that's going to give us 1 over alpha. What I'm doing is just making a common denominator so that alpha is on the bottom of both of these things. So I have alpha plus 1 minus alpha all over alpha. See what I did there? So since they have a common denominator, I can just put them all on the top. And now it's kind of easy to see that, well, alpha minus alpha, those two things are going to cancel there. And so what we're left with is just 1 over alpha. In other words, what's the reciprocal? What's the inverse of 1 over alpha? Oh, well, that's just alpha. So that simplifies our representations quite a bit here. So our final answer is going to be much, much simpler. We can just write it as x equals alpha times m over p. We could call that x star if we want. That's just the demand function for x. Now, let's figure out what the demand function for y for this person is going to look like. And the easiest way to do that is to take our solution that we just got here for x star and plug it in to this expression over here. So let's just combine those two expressions. So plugging in for x there. Break out a little new area over here to work on. So we know the amount of y equals p over q times 1 minus alpha over alpha times x. And we know that x is alpha times the budget divided by p. All right, so let's start simplifying, see what we get here. We have a p here in the numerator, and we have a p here in the denominator, and those two are going to cancel. We could move this q into the denominator here. That might make our lives a little visually simpler. We see an alpha here and an alpha here that are going to cancel. And so when we get done with all that simplification, we're going to have 1 minus alpha in the numerator. And we're moving that q down to the denominator, q, times. And the only thing we have left here is m. Okay, so 1 minus alpha times m divided by q. Okay, so that's our function for y star here, or the Marshallian. And I put some other terms here that sometimes people will call these demands: the Walrasian, Marshallian, ordinary demand, or uncompensated demand. All those words basically mean the same thing. So y equals 1 minus alpha m over q. Now looking at these, this is a general lesson about Marshallian demands that we need to think about. So I'm just going to rewrite our Marshallian demand for x over here, alpha m over p. When you're solving for the demand function for a Cobb-Douglas demand, the way the solution always works out is that the exponent, if it's written in this simplified form like this right here, then basically what the consumer is doing is they're splitting their budget into two parts. The proportion alpha is going to be spent, so alpha m, which is between 0 and 1, that portion of your budget is going to be spent on x. And the rest of your budget, 1 minus alpha m, is going to be spent on y. And then how much y you buy, well, that depends on how expensive y is. So you're just allocating this amount of your budget, 1 minus alpha m to y, spending all that money on y, divided by the price. That tells you how many units you can afford with that amount of your budget. Alpha m, this proportion of your budget is going to be spent on x. How much x you buy is just going to depend on the price of x. So if the price of x or y changes, you're not going to spend more or less money on x or y. You're just going to be able to afford more or less units of y. It's just an interesting side effect that comes from using this Cobb-Douglas kind of function for utility. Okay, now let's do this for B. Now for problem B, when we have this perfect complements kind of utility function here, this method, the standard kind of mathematical methods, break down. Because when you think about the marginal rate of substitution, what is the marginal rate of substitution? What does it mean anyway? Well, the marginal rate of substitution is the slope of an indifference curve. That's not going to work here when your indifference curves are right angles. And the marginal rate of substitution is always either, the slope of that is always either infinity or 0. So you can't use the standard mathematics where you are looking for a tangency between the slope of a budget line and the slope of an indifference curve here. This is where you have to go beyond the math and use your economics thinking skills a little bit. What a perfect complements utility function is assuming that this person wants to always consume this good in fixed proportions. Let's think about that a little more deeply so we can see how we're going to solve this using different reasoning. So let's look at a numerical solution here to get an idea of what these exponents actually mean. So let's suppose that alpha here was 0.2 and 1 minus alpha was 0.8. They have to sum to 1. That's what we're assuming here. And let's assume that we had 4 x's. 4 x's here. We could get 0.2 times 4, or 0.8 utils. But only if, right? Because we're looking at the minimum of two numbers, 0.8 and, well, what would give us 0.8 over here? Well, 0.8 times 1. Okay, so if we had 4 x's and 1 y, then we would get 0.8 utils, right? So let's draw the indifference curve for u equals 0.8. If we get more x's without getting any more y's, we're still going to get 0.8 utils. Why? Well, suppose we had 40 x's. 0.2 times 40 is going to be 8 utils. But we're looking at the minimum of 8 and the product here, 0.8 times 1. So it's not going to give us any more utility unless we get more y as well. And similarly, we could get more y without getting any more x. So what is this telling us? That this person, if they're going to minimize the amount of money they're spending, they're always going to be at a point like this or some multiple that looks like that. What if we had 2 y's? Well, then this person is telling us that they would need 8 x's. They always want to consume in that proportion because the minimum of the product of those two things, 8 x's times 0.2 is 1.6, and 0.8 times 2 is also 1.6. So the minimum are equal. That's the amount of utility. But if you let either one of these drop below that fixed proportion where you want 4 x's for each y, you're not going to get the same amount of utility. So this is what these indifference curves are going to look like. So what this tells us is the proportion, the fixed proportions in which this person's always going to want to consume is related to these exponents. And you're going to want 4 times as many x's for how many y's you want. So in order to get our solution, one of the principles that we've just discovered is that y is going to be only 1/4 as many x's, or x is 4 times the number of y's. At the optimal solution, we know that's going to be true. So how does this relate to the alphas? Since we're not doing a numerical solution, we're doing a general solution here. Well, this is telling us that since we said that here alpha is going to be 0.2 and 1 minus alpha therefore is going to be 0.8, that when we do this solution for x, the amount of x is going to be equal to 1 minus alpha over alpha. Again, 0.8 over 2 would give us that 4y there, y. Or we could write it as y equals alpha over 1 minus alpha x. So now let's do the general solution. So our second equation is going to be the budget line equation. Let me move these over here a little bit. So we just have to pick one of these two to plug into our relationship, price of x times x. So let's just go ahead and plug in for x here. Might as well. So plug that in for x. 1 minus alpha over alpha y plus the price of y times y equals our budget, or the amount of money we have. And let's just solve this for y and see what comes out. So really what we want to do, just consider that a multiplier times y, consider that a multiplier times y, and separate the y's out. So we have p times 1 minus alpha over alpha plus q, all times y equals m. And then we're going to solve that for y and just divide both sides by this large multiplier here. So we're going to end up with something that looks quite ugly. Y equals m divided by that whole thing. Price times 1 minus alpha over alpha plus q. And now we just need to figure out how to solve for x. Probably the easiest thing to do is plug that value for y in over here into this equation that tells us how many x's we're going to get. So let's do that and simplify. So here's what we're going to be looking at to start with, and then we just want to try to figure out some way to simplify that to where that answer does not look quite so ugly. And a common trick, we did this once before, is to try to find a common denominator here on the bottom so that will allow us to cancel some things with regard to this 1 minus alpha over alpha multiplier over here and bring it in. So here's the way I would rewrite this to try to help you see what we're going to do to simplify this. We can just take this numerator, the 1 minus alpha on the top, multiply that times m. So 1 minus alpha times m in the numerator. Let's put this alpha in the denominator down here. As you can think about these things multiplying, multiplying a fraction by a fraction, multiply the top by the top, the bottom by the bottom. So we have alpha times 1 minus alpha over alpha times p plus q, right? So when we multiply this alpha through on the bottom, we can see that these two alphas here are going to cancel. But then we have to multiply that alpha through over here to the q. So we're going to be left with 1 minus alpha times m on the top and 1 minus alpha p on the bottom plus alpha q. Now, it'd be nice if we could just cancel that 1 minus alpha everywhere, but we can't. But what we can do is simplify this a little bit here. To this term on the right over here, let's include a term that includes 1 minus alpha. So again, the trick to do that is 1 is always your friend. 1 is always your friend. So we have 1 minus alpha on the top times m. We have a 1 minus alpha times p on the bottom. What we'd like to have is a 1 minus alpha over here as well. So just multiply that times 1. And it's a special kind of 1. So plus 1 minus alpha divided by 1 minus alpha times alpha q. So now that we have a 1 minus alpha in everything on the top and the bottom, we can cancel that 1 minus alpha here and here and here. And now on the top, we have something much simpler, just m. Down here we have something that's much simpler, just a p. And then we have alpha over 1 minus alpha. So alpha over 1 minus alpha times q, times the price of y. Whew. All right. So now let's regroup our thoughts here. So our two solutions, if we just write those down right next to each other, and let's call this a y star and an x star for consumer B. How can we tell that what we just did makes any sense? How can we tell? Is there some way to check to see if all this stuff is right? Right? That's one of the big worries you have when you're doing an analytical solution. How can you tell if all that junk makes sense? Well, here's one way that we can see if this equation makes sense. We can go back and we can see, remember our original intuition that got us started here. Our original intuition was that x is supposed to be equal to 1 minus alpha over alpha times y. Well, let's see if that's right. Let's see if that's correct. Let's take y, our solution here, and let's multiply it times 1 minus alpha over alpha, and let's see if we get the same expression we have for x here. This is one way to give us some confidence that we've done the right thing. So x equals 1 minus alpha over alpha y. Let's just take our expression for y and multiply it and see what we get. 1 minus alpha over alpha times y. Okay, well, that's m over p times 1 minus alpha over alpha plus q. When we simplify that down, that had better give us x. So by using some tricks very similar to what we've seen before, let's simplify this down. So let's take this top and just multiply it across, the bottom multiply it across, and let's start simplifying and see what we get here. So x, let's write question mark, equals, because we don't know this yet, we just want to make sure this makes sense. 1 minus alpha times m, alpha on the bottom, times p times 1 minus alpha over alpha plus q. You see here that those alphas are going to cancel there, but we have to multiply through the alpha over here. Go ahead and multiply that alpha out. So multiply it out here, multiply it out times the q, and so we're left with 1 minus alpha on the top times m we're left with P times 1 minus alpha on the bottom plus alpha Q. And we're trying to see if we can get this expression to look like our solution for x. So what we want to try to do is get rid of that 1 minus alpha on the top here. Get rid of that 1 minus alpha times P. And we need alpha over 1 minus alpha over here on the Q. Easy enough. We use our simple trick. We just want to multiply Q times 1, but a special kind of 1. 1 minus alpha over 1 minus alpha is 1. And that allows us to cancel. If we divide the entire expression, we see that that cancels. So divide top and bottom by 1 minus alpha. And we're left with m over p plus alpha over 1 minus alpha q. So that checks out. One other thing we could do to see if this solution here makes any sense at all is to see if when we plug this back into a budget equation, what should we get? We should just get m. Right? So if we take this and we say p times x, right, where we plug in this expression here for x, plus qy, we plug in that expression for y, everything here should cancel except for an m. I leave that to you to try as an exercise to see if this worked. Now, I said we were going to do elasticities and some other things, but this video is getting pretty long as it is, so let's end this video here. And if you see anything that I did that is questionable, or if I made any mistakes, it's possible. As I said, I'm just doing this on the fly here. Please let me know in the comments what the question is or what the problem you think you found is, and so that I can straighten that out. And I'll try to come back with a second part to this video where we do the other parts that I saw in this question I found online to look at the aggregate demand function for X for consumers A and B, if we add those together, graphically illustrate what's going on here. We did a little bit of that when we were talking about what these indifference curves look like. And we'll come back and we'll look at how to derive the price elasticity of demand for consumer A and consumer B. So join me for that, but again, please give me some feedback if you have any, or questions if you have any, and I'll join you next time. I hope this has helped you with your economic studies, and as always, good luck.